This is 1969, number 27. So this is called differential equation. This is differential form. So how do you find the original function? It's actually we integrate both sides, right? Basically. And we end up with y equals, because the derivative of what is dy dx? Well, it's y, right? Because that's what that means, derivative of y. And so we basically find the antiderivative of both sides. And now we're stuck because when we were in chapter 3, we never learned the derivative of something is tangent. We just never learned that. And so since we don't know that in our head, what do? We're kind of stuck. But this is, again, whenever you're doing an AP test and you're stuck, I would skip it and come back to it later. And then at this point, you would try rewriting. How can I rewrite this in a new way? And we know tan is sine x over cos x. Now we have something to work with. And this, at this point, u sub is your only option. I mean, of all the integrating things, u sub is the only option. And you have two choices. You can make the top u or the bottom u. And if you experience this enough, it's gonna be the bottom generally, not always. And you can trial and error. Try letting u be the top and you will get stuck. So we are gonna do a u sub, let u equal cos x. The derivative of that would be minus sine x dx. And the question is, do I have this in the original question? And you would say no, but then you would say, now I do. I just multiplied by 1, being negative times negative. And so all the top becomes du, and the bottom becomes u, and everybody knows that's ln of absolute value u plus c. Replace u with what u is. What is u? U is cos x. And there is the answer to that. Is that there? Did I mess up? Let me see what's, oh, I did not mess up. It would appear that I messed up. And you're saying that that answer doesn't appear. Only a positive version. There's none with a negative. Here again is where they're testing your understanding of logs. If you drink too much coffee, what happens? You just need a P. This is a P in front of the log rule. Remember, with exponents, with logs, you're allowed to move exponents up here or move numbers in front. So this can go back and forth. And what is there? You don't see it, but there's a 1 there. They just don't put it because it's obviously 1. You only have one log there. So you're allowed to move this as an exponent. So this becomes ln absolute cos x to the negative 1 power. But what does the negative 1 power do? It flips it and moves it to the bottom. So it's 1 over cos x. But what is 1 over cos x? That is secant x. So that's why we get that. Again, kind of tricky. You feel like you did everything right and your answer doesn't match, and you have to use properties of logs.